Yeah, hello, good afternoon, everyone. This is Dr. Abdul Pasha, Assistant Professor from Institute of Aeronautical Engineering, Dundigal, Hyderabad, from Department of Electrical and Electronics Engineering. So, we are discussing about a course called Power System Operation and Control. So, here it is about IEEE Type 1 model presentation. How can we elaborate the IEEE Type 1 model? And what are its various blocks representations in controller case that we are going to discuss for today's class. IEEE Type 1 exciter. So what is this IEEE Type 1 exciter? So IEEE introduced the Type 1 exciter basically for the power system control and operation. So which describes the exciter component as in schematic editor manner. So what is the schematic editor manner means? This one represents schematic editor manner. The figure 1 shows schematic editor representation of IEEE Type 1 exciter. What it is going to do means which provides the genetic excitation. Which provides the generic excitation for any synchronous machine and which will controls its terminal voltage in generating mode. Basically, we have different modes of operation, generating, controlling modes, and this case it is providing the generic excitation for a given synchronous machine, and also it controls the terminal voltage. The controlling of terminal voltage is also done by this type 1 exciter case in generating mode. So this is given with the reference voltage VD, VQ, VPSS. These are called type 1 exciter systems connecting to the one of the block of the output frequency control VF. So how can we elaborate the components of type 1 exciter means? This will gives the suitable description that type 1 excitation system is representative of the majority of the motor systems which are considered in service case. So it utilizes a DC commutator exciter. That means continuously acting voltage regulator without the exciter saturation function. This is going to be introduced. So here we will derive a simple block diagram for better understanding of IEEE Type 1 exciter model. So here where the main voltage regulator is going to be represented as constants Ka and Ta. So and the exciter is represented by constants Ke and Te case. Constants Ke and Te case, the exciters are represented, whereas main voltage regulator case is represented with Ka and Ta case. These are the main voltage regulator case. Representations of Ka, Ta. These are the main voltage regulators. Main voltage regulators. And exciter is simply represented with the coefficients of Ke and Te. These are one of the exciter constants, Ke and Ta. These are the main voltage regulator constant terms. So here this is about the block diagram of the type 1 exciter case. Here we are considering the blocks, various blocks, which is starting with the reference voltage V reference given to the controlling block here. Controlling block, it is connected, and remaining blocks are associated with Vf naught by Ka, and here VPSS is another block connected, and VD, VQ are the direct and quadrature axis components, which are represented in square root aspect. That means Vd square plus Vq square. And this block is connecting to the 1 by 1 plus TRS coefficient. That means when all the sections are meeting at a junction with the positive coefficients, then the transfer function analysis is represented with 1 plus TCS by TBS. 1 plus TBS. So this block is again connected with Ka by 1 plus TAS. All are the constant terms of the particular regulating system for the type 1 exciter case. And this block is connecting to EFD case and VTF case. That means the resultant will be connecting to the block of EF. So this block will connect about 1 by KE plus TES case. So this block will excite this case, and here our control over VF is going to be done. So feedback path is taken across VF with a transfer function analysis of KFS by 1 plus TFS. So this feedback path is connecting to the one of the summing section. So this summing section is ready to neutralize the whatever the fault or distortions happening onto the system. So likewise, the type 1 exciter is ready to work for the direct and quadrature coefficient terms. And the reference is going to be summated here. And these are excited by Vd and Vq. Then the coefficients are supposed to be enriched with the suitable response of the system. Here, the block diagram contains the number of ports here. One is a reference in, that is the desired value of the stator terminal voltage. The reference voltage is the desired value of the stator terminal voltage. This is to be treated in per unit cases. The power system components are considered in per unit cases. They are supported types as unit manner, int manner, and a real manner. So vector support is not considered here. So when you consider with another port Vd as input section, then Vd component of the terminal voltage will be treated in per unit case. That means they are supported by the one of the types of int and real coefficients. So vector support also here not supported by the Vd case. That's why these are treated as one of the linear variable parameters as a V reference and a Vd case. One more parameter is Vq in, that is a Vq component of the terminal voltage is treated in per unit, and they are supported by the types unit, initial and real coefficients. So vector support is not provided here. So this system is non-quadratic in nature. And one more block is VPSS in. That means this is connecting to the input to a power system network as stabilizer to provide the additional stabilization of the whole power system oscillations of the network. So these are supported by the types of UINT, INT, and real power quotient terms, just like what we discussed. Here also vector support is not supported. So when you treat the output quotient VF, then field voltage for a synchronous machine block is treated. That's value also treated in per unit case. That means they are acting as one of the supported elements as a real term coefficients. Real term coefficients, these are treated, and the vector support is also here not considered. What are the basic features or properties of IEEE 1 type of system when it is acting as an exciter? Those are the things we will see in this simple table. This is the component IEEE type 1 exciter as it is existing with variable parameters. So IEEE Type 1 exciter model is considered here. So this is treated with one of the time constant TR 20E minus 3, main regular gain Ka as about 300, main regulator time constant as 0.001 case, and exciter gain is represented with K suffix E, and a time constant is in TB case, that is also 0, and it is also in TC case, that may also 0. Regulator output will be represented with upper limit, that is positive in sign, that is 11.5 in per unit values. And the lower limit of the output section is regulated with minus 11.5. This is also in per unit value case. So as the regulation gain factor is represented in Kp case, so damping filter can be 0.001 case. So damping filter time constant is about T suffix F, then it is about 0.1 value. So this is in S seconds. And the initial value of field voltage, that is about Vf naught 0.0. And finally, execution rate will be inherent in nature for this system. That means the system responds to the conditions of exciter gain time constants as regulated output voltage only. These are inherent to act to the particular system case. So according to that only the properties are treated for the whole system of exciter one case. So time constant is here represented as a TR. So the type in the terminal voltage transducer time constant is fixed. So it should not have any changes that should be expected from the system. The main regulator gain is represented with the K suffix A and the time constant A. So what happens with this means the type in the values of the time constants are TA and the gain as Ka. Those are represented by first order systems association. That means with the main voltage regulator, these are capable to run the whole system suitably. So exciter gain as represented in Ke and Te, the type in the values of the time constant are represented with the Te and gain Ke. So they are represented by first order system associated with the exciter case. This response is applicable for whole of the system and they may be treated individually to act for this exciter gain system. And time constants of TB and TC, what they will define means type in the time constants as a TB, TC that may be used to model the equivalent time constant parameters. That means they are inherent in the voltage regulator case. So, however, these time constants are only fixed for frequently small enough to be neglected. So, those are only treated to act for these time constants TB and TC case. Regulator output limits and gain. What are regulator outputs and gain? It can capable to control the output voltage limits and maintains the suitable gain for the whole system. That means whatever the type in the values to the upper, then EF max and lower EF minimum output limits of the voltage regulators are treated in per unit case. So upper limit can be constant or variable in nature. If proportional gain Kp is set to 0, the upper limit is constant and equal to EF max. That means Kp is set to a positive value. Upper limit is equals to the product of rectified stator terminal voltage and one of the Kp value fixed case. Next parameter is the damping filter gain, as it is with Kf and time constant Tf. So type in the values of the time constants are Tf and the gain Kf. They are going to be represented by first order system as whole. That means these are associated with the derivative feedback in nature. So when initial values of the field voltage are existing onto the system, then initial value of the field voltage in per unit are property set to 0 and they are currently disabled for whole of the system. We have some parameters related to the IEEE type 1 model. First one is execution rate. What is this execution rate means? The type in the desired signal processing execution rate. What is execution rate means? The type in the desired signal processing execution rate. So this value must be compatible. This value must be compatible with other signal processing components. So that may be of the same circuit or different in nature. So value must be multiple of the fastest execution that should be existing in the whole network. So there can be up to 4 different execution rates. To specify the execution rate, you should use either decimal, which is about 0.001, or exponential values 1 e power minus 3 in seconds case. So alternatively, you can type in inherent, in which case the component will be assigned to execution rate that should be based on execution rate of the component, which is recovering the total whole of the input section. That means it should be receiving the input from all the sections together. Here are some of the definitions which should be involved for better explaining the IEEE type 1 exciter case. So for the purpose of this standard, the following terms are considered. So that is the authoritative dictionary of IEEE only stands that terms or conditions that should be referred to the whole of the network as defined here like this. So that is a AC field breaker. What is AC field breaker means? A circuit breaker used to disconnect the excitation system. Circuit breaker used to disconnect the excitation system from the whole of the power potential transformer. That is called PPT, power potential transformer. Or it may be treated on AC supply. Both are similar. Sometimes it may be treated on AC supply case. So AC voltage regulators case, voltage regulators are best suitable to control over the voltage for the whole of the system. Adjusters. What are adjusters means? A device or function by which the set point is determined is known as one of the adjusters case. Air gap field voltage. So synchronization machine field voltage required to produce rated voltage onto the air gap line of the synchronous machine. So with this field winding at about first case 75 degrees centigrade for field winding, it will be designed to operate at reading with a temperature about 60 degrees centigrade in rise. That means it may happens also less. When it is happens to less means 100 degrees centigrade for field winding designed to operate at a given rating with a temperature rise that must be higher than the 60 degree centigrade. 60 degrees centigrade it is going to be treated or considered. Next parameter to define is air gap line. What is air gap line means? Extended straight line part of the no load. That means saturation of the curve of the whole synchronous machine is going to be treated. So alternator rectifier exciter is considered. That is an exciter whose energy is derived from the alternator and converted to direct current by the rectifier's case. That means exciter includes an alternator, power rectifiers, That may be neither or either non-controlled cases, or it may be sometimes controlled in nature. That may be enlarging the gate circuitry. So it is exclusive of input-output control action terminals. Likewise, it is going to be supposed to operate. So alternator may be driven by any type of the prime mover, usually most commonly by the shaft of the synchronous machine. This will act as one of the excitation system to the whole network. So the rectifiers may be stationary or rotating with the alternator shift. That means automatic control is going to be achieved in excitation control system. As usage, automatic control refers to the maintaining synchronous machine terminal voltage at a given pedestal voltage level without operating actions over the opposite range of the synchronous machine case. Here we need to remember that voltage regulation may be modified by the action of load current compensator. That means power factor or reactive volt amp controllers are going to be treated, and whole power system stabilizers, or it may be constrained by the action of various limiters. So those are all included in the whole excitation network. That means automatic voltage regulator, AVR. That means a term often used to designate either the voltage regulator or alone to the complete control system comprising of the whole limiters case are going to be treated here. And one more thing is synchronous machine regulator auto tracking. So what is the synchronous machine regulating auto tracking means? A function that causes the output of a control channel. That means in the standby mode, it will be following the action of the active control channel. So here, for example, auto tracking of the manual control to flow the automatic control action. This is also known as follower case. So auxiliary winding excitation system is that whose energy is derived from the separate dedicated power winding. That means in that main generator stator voltage is going to be treated here. So brushless exciter. What is brushless exciter means? An alternator whose rectifier and exciter is going to be considered in the suitable time approach case. And this can be connected to the synchronous machine field, thus eliminating the need for brushless case. Bumpless transfer. What is this means? Transfer between two control models or modes that results in negotiable change in the synchronous machine output. So null balance ceiling current, the maximum field current that the excitation system is designed to supply whole of the network case. So typically this is related to the thermal capability of the excitation system. The equipment or synchronous machine field circuit is going to be operated suitably under over-excitation limiter case. So here ceiling voltage is also considered. That means maximum direct voltage that the excitation system is capable to operate for designing to the supply from its terminal case under predefined conditions aspects. So compound source rectifier exciters also treated. So here an exciter whose energy is derived from the currents and potentials of the AC terminals of the whole synchronous machine, and it is being converted to DC by the rectifier circuits. We have half wave, full wave and bridge rectifier circuits. Based on the application we will treat. So exciter includes the power transformers, that is nature in CTs and PTs case. So reactors also required here, and rectifiers that may be either controlled or non-controlled cases, which may include in gate circuitry aspect. So it is exclusive of the input control element, and in excitation system, usage circuit is designed to provide conduction path for field current that may be ready to flow in the preventing excessive field voltage case. So triggered semiconductors also treated with series resistors or inductors, which are commonly used as non-linear resistors that may alternatively provide this function. So here what happens means boosting of the current taking place, that may be with an excitation system with auxiliary supply that acts to increase the available power supply, that to be to the field winding and typically during the fault conditions case. So here the terminal voltage is little bit less and the current is also to be more than the normal cases. So current boosters will helps to excite whose energy is derived from the currents at the AC terminals of the whole synchronous system, and that may be converted to direct current by the rectifier circuit. So current boosting system's output is going to be added directly with a potential source exciter that should be given to the rectifier circuit as a separate rectification process. So current boosting systems may include power current transformers, either non-controlled rectifiers or controlled cases. So these rectifiers with gated circuit will have suitable control over the action. That means DC field breaker, that is a breaker used to disconnect the whole excitation system, that is from the generator or exciter field. So de-excitation, the DC generator commutator exciter will have energy which is considered from the DC generator circuits. So exciter includes DC generator with commutator and brushes, and it is exclusively of the input control elements. So exciter may be driven by motor or some other type of device like prime mover, most commonly by the shaft of the whole synchronous machine. It is going to be treated or considered. So DC regulators are mostly preferred as manual control excitation. This will remove the excitation and field winding discharge coefficients of the whole synchronous machine set. This will be connecting to the main exciter or pilot exciter cases. So here one thing we need to remember that DC excitation may be accomplished by various means like field discharge circuit breaker, DC field breaker, AC field breakers, crowbar setups, freewheeling diode, and phase back control of the controlled rectifiers. And also the total combination may also treat for functioning of the whole system. This gives the suitable good results of the whole network. So these are some of the references whichever I have treated, and this lecture presentations gives you the most valuable information in the whole network. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.